You know the pop-up session convener, you get called at the last moment. This is a video, this is an animation of a CWEMF run for Shasta Reservoir for a year. Don't worry what year it is, calibrated, non-calibrated. We're just going to watch the dynamics of this as we go through it to illustrate the effect of a two-dimensional representation of the reservoir versus a one-dimensional representation. This will be vertically and longitudinal, so you can see some of the attributes of the reservoir. And I hope this works. I have no idea how to make this work on this particular version. There you go. All right, so we start off by just washing the initial condition out here. We're on day 8, 9, 10. The reservoir has cold water coming in. There's a Pitt River arm, Sacramento River arm, Cloud arm. It's kind of isothermal, a little bit cooler right here. As cold water comes in, the main tributaries in the winter months. I'm an engineer on one. Okay, so you can see the reservoir here in February. There's like warm spells like we get, a little bit of heating. The black line here is 50 degrees Fahrenheit, 10 degrees Celsius. So this is all pretty much 10 or less. Tributaries are all well connected. Waters are coming in. They are replenishing the cold water pool at this time of year. There is no cold water pool at this time of year. The whole thing is cold water, okay? If we call 50 degrees or 10 C cold. You'll see little bits and pieces here where there's a little bit of atmospheric heat flux that is trying to get this reservoir to stratify a little bit, but it will come and it will go. This is 1 year. We have other years. You don't know when it's really going to settle in and stratify. It will begin to put some heat on there and then it'll go away. If you have a late storm, like this freeze we had a couple weeks ago, probably would have broken up any stratification that was there this year. But it does get to a point where it starts to persist, and you do see the tributary, the Pitt River, disconnect. Sacramento River is disconnected, and the Cloud River is disconnected. This is a small creek. Don't pay much attention to it. Once in a while, you'll see a little bit sneak back in there. So what happens is some cold weather comes, some snowmelt. It's not really snowmelt in this system because the snowmelt source is so far away from the reservoir, and the reservoir is not very high elevation. Once you get into June, I'm stratified. I've got a well-defined cold water pool. Actually, probably around May 1st, I have got a well-defined cold water pool. And it just is now working through here. You can see this. These are this upper level, middle level, low level, and side gates. SL, that's a G, should be a G. Those are the intakes for the temperature control device and where they're pulling water from at different times of year. You can see the reservoir experience is very strong stratification, a very horizontal stratification. It is not, reclamation takes a profile down near the dam. That's sufficient for modeling through the summer cold water pool. If you want to look at dynamics about how water gets into this lake, when it reconnects, when you lose your connection from your tributaries, which are contributing to your cold water pool, you might want to do some seasonal modeling, monitoring up in these areas to check that out. You'd also need the tributary inflows to get there. The system is just like a layer cake. Now here you can see, once we get to August 1st, at this latitude, our river temperatures begin to fall. Okay? So you can see that the Pitt River's coming in cool. McCloud, not a lot of water there. Just a little bit is sneaking in at the top, but it's not cold enough to replenish the cold water pool. It's just sitting there, being utilized, being evacuated, and it's slowly degrading because of wind mixing and heat diffusion into the reservoir. So we're losing that cold water pool. September, we have these critical time in the river for fisheries temperature management. I'm getting cold water replenishment here, not much here, but I'm not getting it cold enough, and it's not in a position to reach the cold water pool to help give me any relief. It's mid-October right now. Can't see that very well, but that's what the date is. The whole system is cooling off. It's becoming isothermal. The epilimnion is deepening because we have wind mixing and less atmospheric heat exchange. And then we get to the end of October, you finally see a little bit of cold water, but it's not cold enough to connect quite yet. It's just working its way through the system, and you'll see we're on November 15th. I didn't time this, Nigel. I'm not sure I'm going to make it. There's a little cold water right there, November 21st. It's Thanksgiving. The Pitt River's trying to connect. We can't get these other systems to connect yet. And then finally around December, we're back to replenishing our cold water pool in Shasta Reservoir. In January, the thing will turn over completely. We'll be back to the isothermal condition. So it's just an animation to illustrate that range of conditions that occurs over a 12-month period. Thank you.